Hello everyone, welcome you all to AI Ki Pathshala. I am your host Anu, and today we are going to study median in iris dataset. So, we saw a while ago that the concepts like mean, variance, and standard deviation can be corrected very easily if you have one or a small number of outliers or extreme points. So these three gets very easily effective. So for me, we have something called median. This is, you can say, replacement for mean. So let's understand what a median is. And before we go and understand how to compute a median, what median is, let me show you that it has the same behavior that we want. What we want? That it should not get corrupted by any small number of outliers. So first of all, let's write some simple code here to calculate the median. What I'm going to do, I'm going to simply copy this code. Let's take this code and I am copying this entire code and I'm going to paste it here. Fine. And I will make some changes here itself. So here, instead of this means, let's write medians. Fine. And earlier we were calculating the mean. Now this time I am calculating the median. So let's change it to median. Give it a median. Here also, let's write median. MEDIN median. Here also, let's write median. And this last line also, just change it to median. Fine. So we have, this is the median. Now let's run this piece of code. So we get this value. Now, let's understand what this is. So again, this median can be computed very easily. This median can be computed very easily because NumPy has this function median, np dot median. So my first value that I am printing here is a median of all Setosa flowers. My second value that I am printing here, this is my second value that I am printing here is I am taking all the Setosa values and I am appending a value of 50, which is an extreme outlier, right? Because all my values of Setosas has petal length between 1 and 2. We know that all Setosas has a value between 1 and 2. 1 and 2, all Setosa are lying between, this is 1 and 2. And here what I have done, I have added one extreme outliers, which is 50. And then I have calculated the median again by adding an extreme outlier 50 here. So I am getting this value median, which you can say, see, same as my previous value before adding an outlier. Different. In case of mean, this mean value, this is the median, but in case of mean, the mean with outliers, and without outliers, were significantly different. We saw that. But here we can see the median with an outlier and without an outlier is exactly the same. Now, the third thing that I am printing here is the median of this versicolor flowers, petal length. And the fourth one I am printing is Virginica petal length, median of Virginica petal length. Now let's look at these four values. So see these four values. So the median petal length for setosa is 1.5. We can see this. And this is the median petal length for setosa is, the median petal length for setosa is 1.3. This is the median with an outlier. This is the median with an outlier. But it's exactly same without the outlier. This is the type of behavior that we require. And the median value for versicolor and versinica are 4.35 and 5.55. Now these numbers 1.5, 4.35 and 5.5 are very close to the values of mean that we saw a while ago. And if you look at these numbers of means, let's go here. If you see here the mean code, let me, yes, this is the code for this value of mean is with outlier and this value of mean is without outlier. So which is significantly different for the mean without outlier and with an outlier. But here we had 1.55. In this case, we have 1.5 and 4.35 and 5.55, which is very similar to these numbers. Fine. So median value for all of them tends to look very similar to your mean, which means intuitively it's very similar to a mean or central tendency. Mean or central tendency, which you have wrote central tendency or mean, because mean represents central tendency. Fine. We talked earlier about mean being a central tendency value. That's why I have written here. But it has a nice property that with one outlier or a small number of outliers, the value you get is very similar to the value you get without the outlier in case of median. So let's understand how to compute the median. Let's assume I'm given 7 numbers or 7 observations. 7 numbers or 7 observations. So I'm just speaking a simple example here. So let's assume I'm given this observation where my values are 1, 1.2, 1.1, 2.1, 1.8, 1.8, 1.6, 1.2. Fine. So let's assume this is my observation. And let's assume this is my x. I am putting this as x. So this is my set of observations for a variable x. Okay. So this could be your petal length, it could be your sepal length or anything. Now, the median of this is computed as follows. How you can compute the median? So the first step to compute the median, step 1 to compute the median is, first I sort these values. What I do? I sort these values. So I will sort these values in either increasing order or decreasing order, any order that you like. So I will just choose increasing order for now, right? So if I sort them, what I get is, after sorting, my values will be like here 1, 1.1, 1.2, 1.2, 1.6, 1.8, 2.1. Fine. Right? So this is these are the values I have after sorting. And here I'm choosing increasing order for sorting this value. So this is the first value, first number. This is my second number. third number, fourth number, fifth number, sixth number, and seventh number. So once I have sorted them, pick the middle value. That's the second step. So my step 2 is, after sorting, pick the middle value. Pick middle value. Fine. So now the question arises, what is the middle value? Let's understand what is the middle value. I would say that fourth is my middle value. Which is the fourth value? I will say, let me take some other color. 1, 2, 3, 4. So this is my fourth value. So you will see, I will say this is my middle value. Why this is my middle value? I have 3 numbers to the left of this 1, 2, 3, and 3 numbers 1, 2, 3 to the right of it. And what is the fourth value? 1.2 is my fourth value. Since 3 number is to the left of 1.3, 1.2, and 3 number to the right of 1.3, that's why it lies in the middle. So this is my middle value. But since 7, so how many total values are there here? 7 are the total values here. And I know 7 is an odd number. So what I'm doing here is 7 plus 1 by 2, which is equal to 4. Since 7 is odd, we will see that what happens if the number of data points is even, right? Right now, I am seeing the odd number of values. So what actually, so all I am doing here is, I have, let's say, n numbers. So I will just do n plus 1 by 2. That is my median value. So after sorting, if my number of observations or values is odd, if n is odd, so what I will do n plus 1 by 2. Whatever will come, in this case 4 is coming, that is fourth is my middle value. So this is first, second, this is third, and this is fourth. That will tell me the index. Basically here fourth refers to index. It's very important. 4 refers to index. That is the fourth. So these are the indices, right? So I have at the first indices, I have 1. At the second index, I have 1.1. At the third index, I have 1.2. And so on and so forth till 2.1. So my central value here is 1.2. Now, why this is useful? Now, I could declare that my middle value is my median. So my median of x is nothing but 1.2. This is a very simple concept. So basically, what you do is, you sort the number and pick the middle value. Now, the immediate question is, you might have is, what if I have even number of points? Because here I have odd number of points. So let's do a simple experiment here. So imagine if I have one more point here, which is, let's say, 1.8. Let's assume. So take me to the next page. So after I add one more point here, let's say 1.8. So how will be my new list will be? My new observations are like 1, 1.1, 1.2, 1.2, 1.6, 1.8, 1.8, 2.1. So this is my new observation. And here how will my sorting look like? This is my sorted value. Here I already sorted the value. So let's check 1, 2, 3, 4, 5, 6, 7, 8. Because I have added one more part to make it a even. So here my, let's say here x is this, and this is a This is my number of observations we here. So this is the first number. This is second, third, fourth, and fifth, and so on, so on, till eighth number. Now here 8 is where n is equal to 8, and 8 is my even number. So now, if I do here n plus 1 by 2, what I will get? I will get 8 plus 1 by 2 is equal to 4.5. And there is no 4.5 or 4.5 here, right? There is no 4.5 here because I need integer value. So what we do is a very simple hack, right? So we know that the central number is somewhere between 4 and 5. So if you check 1, 2, 3, 4, so central number is somewhere between 4 and 5. This is my fourth value. This is my fifth value. If you club these two values together, so there is 3 values before this and there is 3 value after this. Now these two are the middle values in this case. So because there are 4 numbers here and 4 numbers here, 4 numbers are here and 4 numbers, so I have taken, but there is no 4.5 value, right? So what I do, I take the fourth value, I take the fifth value and compute the simple mean of both of them. So my fourth value is 1.2 and my fifth value is 1.6. If I calculate the mean of these two values, so what is the average of both of them? It will come out to be 1.4. Now, I will declare that the median of all my points is this. This is my median value. So all my points here, my median of x, I will declare it to be 4.5. Now, so if n is even, basically what you do is you take n by 2 points, you basically take n by 2 points, then you add plus 1. So basically you take n by 2 points, the point at n by 2 index and the point at n by 2 index. So you will take these two indexes, the point at n by 2 index and point at n by 2 plus 1. So these are the two index you will take. These are the two values at these two indexes. At here n by 2 is 8 by 2, that is 4, and n by 2 plus 1 is 5. So this is the index at the fourth position I am taking here, and this is the index at the fifth position I am taking, and I am adding these two, or I am calculating the average of these two index values, which I am getting as 1.4, and this I am declaring as the median of my data set or my median of this observations. So you understand? So now the immediate question I have is, why is median not getting corrupted by an outliers? Again, let's look at a bunch of numbers. I'm going to do, I'm going to create a new data set, which is x dash, which is exactly the same numbers, right? I'm just copying these numbers in the next sheet and creating a new data set, which is x dash. So let's create a new data set or new observation, which I am putting as x dash. Fine. And let's put the observations values here. 1, let's say this is 1.1, this is 1.2, this is 1.4, this is 1.6, this is again 1.6, 1.8, and my last value I have written, let's write something like 68. Fine. So how many points are there? 1, 2, 3, 4, 5, 6, 7, and my 8th observation I have written 68. So this is a number which is 68. Obviously, this is an outlier number because all these numbers are rounded between 1 and 2. My 7 observations lies between 1 and 2, except this 68. So this is your outlier. This value is my outlier. This value is my outlier. Understand this? Or you can say this is your erroneous point. Now what we did, the difference between x and x dash is nothing, but just one observation. There is no difference between one x and x dash, only the difference is in one observation. So now we know that the median of x, was, the previous median of x was 1.4. Fine. Median of x was 1.4, we know. So now we have many indices. Again, 1, 2, 3, 4, 5, 6, 10, 8. So I have to take the fourth and fifth value here. Fourth and fifth value. What is my fourth value? First, second, third, fourth. This is my fourth and this is my fifth value again. If I will take the fourth value and fifth value and calculate the average, and I will calculate the average of both, I will get, let's say this is 1.4 plus this is 1.6 by 2. This will come out to be 1.5. Fine. So average of both of them is 1.5. So median of x dash will be, this is my median. So median of x dash will be, this is my median. Median of x dash is equal to 1.5. Now which is very similar to your mean, right? This is my mean. 1 point here, 1 point, which is median is 1.5, which is very similar to your mean. So what's happening here is, by just adding 1 point, instead of taking the fourth value, you are taking the average between the fourth and the fifth value, right? So one nice property about median is, if you have a small number of erroneous point or outliers, it can't corrupt your value of median much. Because my median value, earlier my median value was like 1.4. Now it is coming out to be 1.5, which is very close ones. So this is a very nice property about median, that if you have a small number of outliers or erroneous points, it can't corrupt your values of median much. Now, the next question is, what if out of these 7 values, 4 of them are, let's say, wrong, or they are some extreme values. So let's take the extreme case, right? Let me open next page here. So let's take the extreme case. Let's define x double dash here. Let's define x double dash here. Fine. So let's assume I have, in this x double dash, I have these observations. This is 1. This is 1.1. This is, let's say, 1.2. This is, let's say, 5. This is, let's say, 10. This is, let's say, 20. This is, let's say, 30. 1, 2, 3, 4, 5, 6, 7. So let's say we have 7 observations. So what's happening here is, again, I have 1 till 7 points. So, but what is the problem here is, I have more than half of my points which are corrupted. See, these are my points These are 4 points and these are my 3 points. This is 3 and this is 4. Total 7 points are there. So you can see more than half of my points are corrupted. That is, they are an outliers. So let's assume all these are corrupted. So all these are, so you can say these are my good points. You can say these are my good points. These are my good points or clean points, good points or clean points. You can say CLEAN, clean points. And these are my corrupted points. These are my corrupted points, corrupted points, or you can say outliers. So if more than 50% of my points are corrupted, what is the mean or median of X double dash here? What is the mean and median of X double dash here? So the median of X double dash here is, what is the median of X double dash here? This is my middle value because there are odd number of points here, 1, 2, 3, 4, 5, 6, 7. So fourth is my middle value because 3 values lies after this and 3 values lies before this. So here median of X double dash is equal to 5, which comes out to be 5. Fine. So central value here is, what is the central value? Is 4. So that what it means. So if more than 50% of your points are corrupted, only then median gets corrupted. This is very important to understand. If 50% of my points are corrupted, 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 then only my median get corrupted. Fine. Because here you can see my median was corrupted very much because 4 of my points are corrupted. That's why. And this is a very interesting observation. So some people could argue that these are clean points and these are the outlier points. So the way to look at it, so for computation of median, as long as less than 50% of your points are corrupted, your median will still remain sensible and same, unlike your mean. So median is equivalent to mean, and it's very, very simple to compute. All you have to do is simply sort and pick the middle value. This is extremely simple. So that's all for the today's session. In the next session, we will discuss about percentile and quantile. See you in the next session. Keep learning, keep smiling. Thank you. Take care. Bye-bye.